We're going to take a look at some more quotient rule with negative exponents, more advanced questions. So we have here in the numerator a to the negative 7, b to the negative 4th, c to the 9th power, all of that divided by a to the 8th, b squared, c to the negative 1. So I'm going to solve this two ways. I'm going to start with just using the quotient rule. So we have a quotient and we're going to subtract the exponents. So we start with looking at our factors of a. We have a to the negative 7 minus 8, b to the negative 4 minus 2, c to the 9th minus negative 1. Careful on that one. So we get a to the negative 15, b to the negative 6, and the 9 minus negative 1 is equivalent to saying 9 plus 1. So that gives us c to the 10th. Now the directions say we must write our answer without negative exponents. So we'll need to think about this as being over 1. And we'll take a to the negative 15 and b to the negative 6 across the fraction bar. So we're going to end up with, in the numerator, c to the 10th, but in the denominator, we'll have a to the 15th. Notice how the exponent is now positive, times b to the 6th. Okay, we'll start back from the beginning. We'll try this question again. So we have a to the negative 7, b to the negative 4, c to the 9, divided by a to the 8th, b squared, c to the negative 1. So now, sometimes people prefer, which is myself included, to take the reciprocal of the factors that have a negative exponent to begin. So I'm going to rewrite this question as, starting with the numerator, a to the negative 7, I'm going to put in the denominator as a to the 7th. Then b to the negative 4th goes in the denominator as b to the 4th. C to the 9th stays where it's at, so it's in the numerator, it's going to stay. Now in the denominator, I have a to the 8th, it's going to stay in the denominator. B squared, that's going to stay in the denominator. C to the negative 1, I'm going to take across the fraction bar and put it in the numerator as c to the 1st power. Now that all of my exponents are positive, I'm going to simplify. So in the numerator, I have two factors of c. We have c to the 9th and c to the 1st power. C to the 9 plus 1, which is going to give me c to the 10th. Then in the denominator, a to the 7th and a to the 8th. So a to the 7 plus 8, that's going to give me a to the 15th. And then in the denominator, b to the 4th and b squared, b to the 4 plus 2, that's going to give me b to the 6th. Notice how we get the same answer, slightly different process, and both are okay. So I want you to try the following question. A to the negative 7 times b to the negative 1 times c to the negative 4. All of this being divided by a cubed, b to the 5th, c to the 9th. Go ahead and pause the video. If you want, try it both ways. All right, so let's try this. First way is just using the quotient rule, which says to subtract the exponents. So I would do a to the negative 7 minus 3 times b to the negative 1 minus 5 times c to the ninth, c to the negative fourth minus 9. So we have a to the negative 10 times b to the negative 6 times c to the negative 13. And we do need to write our answer without negative exponents. So we want to think about all of these as being over 1. And every factor needs to go across the fraction bar because each of these has a negative exponent. So we have a to the 10th in the denominator, b to the 6th in the denominator, c to the 13th in the denominator, and in our numerator we have 1. All right, alternative to that would be beginning with taking the reciprocals of any factor that has a negative exponent. So if I start with my numerator, every factor is being taken across the fraction bar. A to the negative 7, b to the negative 1, c to the negative 4, all go across the fraction bar. So write that in the denominator as a to the 7th, b, I'll put to the first power, c to the 4th. In the denominator, we still have a cubed, b to the 5th, c to the 9th. And our numerator is 1. Okay, at this point, we have a product, so we would add our exponents. So we have still 1 in the numerator, but in the denominator, we have a to the 7th plus 3, b to the 1st plus 5, c to the 4th plus 9. All right, so we end with a to the 10th times b to the 6th times c to the 13th. And as you can see here, we have the same answer as we got the first time.